Hi, everybody. This is Morgan here with Positive Approach to Math. Moving right along in our equations topic, we are solving multi-step equations part 2. So we're adding a little bit more before we boil it down to our two-step process to solving equations. Just a friendly reminder, if you need a PDF of this lesson, a blank template, with the lesson information and the U-Try, you can look in the details down below, and there should be a link where you can download it, or you can download it to print or download it to doodle on for some tablet. There is also a link to the answer key for the U-Tries if you get to try them on your own and you want to check your work. And then there's a link to a video of those U-Tries just in case you got stuck on any or just want to do a couple more with me. That is there too. So I'm looking forward to starting this lesson. We are putting some of our skills from last topic to play here. We're bringing back the distributive property and combining like terms, which are super fun to utilize when we're solving equations. So here we go. So what we did is we did one step, then we did two step. Now everything will boil down when solving equations to a two-step equation. There's just some extra steps that sometimes go above and beyond, but once you take care of them, you're gonna see everything boils down to looking like a two-step equation, okay? You, just like we put it all together in our algebraic expressions topic, we taught you how to distribute and then combine like terms. And the reason why we did that was for right here, because sometimes you're gonna have parentheses in your equation, which is gonna require you to distribute. But sometimes you're also going to have like terms after those parentheses, so you need to combine like terms. So same thing goes for when we put it all together back in our first topic. You want to apply the distributive property first, and then you're going to want to simplify by combining like terms, okay? And so basically what we want to do is we want to simplify the left-hand side as best we can. If there's anything we need to simplify there, simplify the right-hand side the best we can, okay? And I want to point out that when you are simplifying a side, you're not trying to do an opposite operation. So I always say simplify side. I always make the note you're doing the same operation that you see. You're just combining like terms. So if you see 5 plus 3, you're doing 5 plus 3 and squeezing them together. You're not going to say, oh, I need to do the opposite. The only time you're going to do the opposite operation is when you have to move over the bridge. And I'm sorry, my handwriting is not the best when I'm super zoomed in here. So only time that I would apply the inverse operation is when I'm working to get the actual variable by itself. When I'm just simplifying and working with what I got to simplify one side, I'm not yet striving to get the variable by itself, so I'm not doing the opposite operation. Okay, so let's dive right into it. Okay. You know what I'm going to do. I'm going to draw a line down my equal sign. The line's getting longer, which is meaning more steps. And first I'm going to say, okay, do I have any parentheses? And the answer is yes. So I'm going to distribute. And this is why we drill all those skills, because they all come into play. It's really crazy how math works. It all builds. You're getting an awesome toolkit so you can recognize it. And utilize those skills when they come up. So we're going to do 3 times x, which will leave us with 3x, and 3 times -2, which will leave us with -6. And that right-hand side is just a singular value. It's going to stay 24. So I'm going to look at that left-hand side, and I'm going to say, is there anything else I can simplify? So I did do my distributive property, but now are there any like terms I can combine? And the answer is no. So now it's gonna boil down to what we just did in lesson 2, the two-step equation. So I'm gonna put my 3x in my box. I'm going to say, okay, how am I going to move that -6 over? I need to get rid of the -6. It needs to move over to the other side. So that means I need to do the opposite operation. Maybe you're like, oh, I could do this part by myself. And if you can, awesome. And then I'm going to bring down that 3x. 24 plus 6 is 30. And then we're going to say, okay, now we need to get the x really by itself, right? Those things are glued together with multiplication. And so the opposite of multiplying by 3 would be to divide by 3. And you're going to see as we get down to the 2-step, and we're left with x is 10. And what I was going to say is you're going to see as we get down to the 2-step process, I am going to move a little bit quicker because hopefully that is becoming more and more familiar. But what I also want to ask you is, okay, I got x equals 10. Is there a way that I can see if I got the right answer? And hopefully you're saying we can always check our work. So don't be scared because of that parenthesis there. You can still plug in 10 and see if that will give you 24. So you would do parentheses first. 10 minus 2 is 8. 3 times 8 is 24. So it all checks out. So we can always, always, always check our work still with all these steps, okay? So that was one where we just had distributing. Let's look at our next example. I don't see any parentheses here, so I don't have anything to distribute, but I do see a couple terms on that left-hand side, and hopefully we can simplify them. So if I'm looking at that left-hand side, I see I have an 8x and a -3x. So they're on the same side. I just want to simplify. So what's going to happen, I'm going to go back to my underlining, and I'm going to combine them exactly as they are. I'm not doing any opposite operation because I'm not moving over my bridge. I'm same side, simplify. Okay, that's what I tell myself. So I'm just going to do 8x as I see it, -3x. We're just going to combine like terms. 8x minus 3x will leave us with 5x. And then that plus 2 does not have any like terms that go with it. So I'm just going to bring it down. And it's going to equal 17. Now, hopefully you see, what did it boil down to? A 2-step equation. So we're going to put that 5x in the box. I'm going to ask you, and hopefully you can say what's going to happen to yourself or out loud. How will I get that plus 2 over to the other side? I am going to subtract 2. If I do it on the left, I must do it on the right. I draw my arrow down. 17 minus 2 is 15. And now my next question for you is, how am I going to get that x by itself? What am I going to do with that 5? And hopefully you're answering. Divide by, or sorry, not by 2. Divide by 5, right? So we're going to divide both sides by 5. And we get x equals 3. I'm going to say, where did that come up with 2 from? But it's right there. Okay, so we just had to combine like terms. What's important to note is 5x minus 3x, you do the signs you see. So we did not switch it to plus 3x. Same side, simplify, same operation. Okay, moving right along. Ooh, there's a 5th one. I did not see that. We are looking, I'm going to draw okay. Moving right along. We are looking at something where I have a feeling it's going to have both distribute and combining like terms. So let's take a look here. If I look at this problem, I see 4x plus 2, and then I see parentheses. So remember that 4x, we just bring it on down. This 2, we will distribute. So that's going to become plus 2x. And then 2 times -5 will give us -10. Remember, distribute means to multiply. okay? Now, if I look there, not quite a two-step equation yet. Still a little bit more simplifying that needs to be done. So no more parentheses, so no more distributing. But do we have like terms now? Can I condense anything on that left-hand side and combine any like terms before I get it to that two-step equation process? And the answer is yes. I see a 4x and I see a 2x, right? Same side, simplify. So I'm going to do the same operation that I see. 4 plus 2 will give us a 6x. And from there, we can bring down that minus 10. That didn't have any friends, and it's going to equal 8. Now we're cooking with a two-step equation. So now I'm going to put that 6x in its box. Oh, no, I need my green. Got one step ahead of you, sorry. So now I'm going to say, okay, I need to add 10, bring down the 6x, and then hopefully you know the last step there to get that 6 over to the other side. It's really 6 times x. So we want to divide both sides by 6. And look at that. I ran out of space for that orange line. I'm going to squeeze in my answer right here. X equals 3. Awesome. Okay. Next example here, we have our variables on the right. So we're bringing it back to that guy. So let's talk about how we would go through that. Something tells me I should draw a ooh, I don't like that. I should draw a really long line. Okay. 28. Bring that down. 5. Bring that down. Little tiny arrow. Okay. Let's distribute this negative. Remember, that's like having a -1 in front. So we're going to do -1 times x, which will leave us with -1x. You can just write -x, that's okay. And -1 times -3 will give us a +3. And then I'm going to bring down my plus 5x. Okay, let's look. Do we have any like terms on that right-hand side? And the answer is yes. And we have more than one set of like terms. We have our variable, -1x, and +5x, so we can combine them. Same side, same operation, it's just on the right-hand side instead of the left. -1x plus 5x will give us 4x, and then we have our constants, 5 plus 3, which will give us plus 8, okay? And so we didn't have to bring anything down on that right-hand side because something combined it with something else. And remember, same side, same operation. Okay. Now, from here, we're going to put our 4x in our box. Maybe you know what's happening, right? I need to get rid of that plus 8. I want to isolate my variable. I'm ready to go. So I'm going to get rid of that plus 8. And I do that by subtracting 8, leaving me with 20 equals 4x. And last but not least, I have 4 times x. So I want to divide both sides by 4. And so that's going to leave me with 5 equals x, or we can write that as x equals 5. Cool. Okay, last example here. We are going to draw our line down the equal sign. The only difference here is we're distributing a fraction. And we've done that when we went through our distributing practice. So that's going to give us 2/3 times x. So I'm going to write that as 2/3 x glued together there. And then we're going to have 2/3, kind of going over my other problem, times -18, which if you type that in your calculator and do 2/3 times -18, it should leave you with a -12. So you can put -12. If you did it in your head, you should get -36 divided by 3, which will give you -12. And that's going to equal 24. Okay. We are going to put our 2/3 x in the box, okay? And now we're going to add 12 to both sides. Okay, so that's going to, I'm just seeing if I have enough room here. That's going to give us 2/3 x equals 36. Okie dokie. And then we're going to talk about this. We have a fraction here. So we have a fraction times a variable. So my question to you is, if you remember back from one step, what do we do when we have a fraction times our variable? Yes, it's not wrong to go ahead and say, oh, let's divide both sides by 2/3, but we have another little trick that will save us a little bit of steps here, or a little bit of time, I should say, and that is multiply by the reciprocal. So when your coefficient for your variable is a fraction, we think of multiply by the reciprocal. If I multiply the left-hand side by that reciprocal, I'm going to multiply that right-hand side as well. Here, this one, you might, I'm going to just write it over here. Once your calculator, you're going to do 36 times 3/2. That should leave us with 54. Okay? So those are our examples for the second part of multi-step equations. So some summaries, or a summary and some helpful hints, is make sure you condense each side of your equation before you start moving things over. So condense your left-hand side, make sure there's no parentheses from distributing, make sure there's no like terms to combine. Once you do those two things, then you're ready to apply your inverse operations and move things over to other sides. Same side, simplify, same operation. Everything, as we see, boils down to a two-step equation. So we combine like terms, distribute, all that good stuff, and then it's a two-step equation. And when in doubt, I told you you're going to see this every lesson here, you can always check your work. Okay, so I left you with 6 problems. Some of them are a little bit spicier than others. Please give them a try to make sure you have this skill down before we move on to adding a variable on both sides of that equal sign. So that will be lesson 4, and you can, like I said, check your work in the details below. There's a key or there's a video if you want some guidance on those U-tries. Keep up the great work, guys. See you soon.